So let me solve another simple problem on simple stresses and strains. A 200 millimeter long steel bar has circular cross section 25 millimeter diameter. Determine the stress, deformation and axial strain induced in the bar when it is subjected to a compressive force of 40 kilonewton. So modulus of elasticity 200 GPa. So here length of the rod is 200 millimeter and the diameter of the rod is 25 millimeter. So load acting on the bar is 40 kilonewton. So it can be written as 40 into 10 raised to 3 Newton. So Young's modulus 200 GPa. So we know 200 GPa. So giga means 10 raised to 9. Pascal means Newton per meter square. So convert this 200 into 10 raised to 9 Newton per meter square to Newton per millimeter square. So for which 200 into 10 raised to 9. To convert this meter square to millimeter square, so we have to divide it by 10 raised to 6. So in the numerator you have 10 raised to 9. In denominator you have 10 raised to 6. So it will be 200 into 10 raised to 3 Newton per millimeter square. So here the diameter is 25 millimeter. So you can work out the area. So cross sectional area A equals, so pi d square divided by 4. So pi into, so diameter it is 25 square divided by 4. So area you will get 490.87 millimeter square. So it is cross sectional area of the bar. So first calculate the stress induced in the bar. So stress sigma equals P divided by A. So here the load is 40 into 10 raised to 3 Newton divided by cross sectional area, it is 490.87 millimeter square. So if you solve this, you will get stress as 81.48 Newton per millimeter square. Next, let me determine the strain. So strain epsilon equals stress divided by Young's modulus. So stress 81.48 Newton per millimeter square. So here the Young's modulus is 200 into 10 raised to 3 Newton per millimeter square. So Newton per millimeter square divided by Newton per millimeter square. It will be cancelled. Okay. So on simplifying this, you will get strain as, so strain epsilon as 0.407 into 10 raised to minus 3. Okay. So let me calculate the deformation, that is delta L. So you know the formula, delta L equals PL divided by AE. So here load is 40 into 10 raised to 3 Newton multiplied by length 200 millimeter divided by cross-sectional area of the material 490.87 millimeter square, and Young's modulus, it is 200 into 10 raised to 3 Newton per millimeter square. So if you simplify this, you will get elongation delta L as 0.0814 millimeters. So these are my final answers. One is stress 81.48 Newton per millimeter square. Another one is strain 0.407 into 10 raised to minus 3. So elongation 0.0814 millimeters.